Hello everyone and welcome back. In this video we're going to cover how to solve some inequalities. So I think the best thing we can do now is just cover some examples. We're going to cover examples that use both the multiplication principle and the addition principle in a single problem. So let's just go over an example here. This is actually problem number 37 in the text on page 232 in my text. And the problem is 3x plus 1 is less than 7. It asks us to solve the inequality, then graph it, and then write the solution using set builder notation and using interval notation. So let's get into it, guys. So we'll solve this just like it's an equation. Imagine just like there's an equal sign right here. What would you do in that situation? Well, you would first subtract 1 from both sides. These cancel. We're left with 3x is less than 6. So we just use the addition principle there. And now the multiplication principle, or you can think about it really as the division principle too. We can just divide both sides by 3. Equivalently, it's like multiplying both sides by a third. But anyway, we divide both sides by 3. Those cancel. So we get x is less than 2. That is the solution to this inequality. Now what they want us to do is they want us to graph this solution and then state it in both set builder notation and in interval notation. So to start, let's graph it. So let's say we have a long number line here. Say 0's in the middle. We'll imagine negative infinities on the end over here and positive infinities on the end. Even though we're being a little bit informal, you never actually touch infinity, you never actually touch minus infinity, but this is just a conceptual aid. And now x is less than 2, so we need to plot off the number 2 on here. 1, 2, and I'll plot off some negative numbers as well. -2, -3. All right, so x is less than 2. Notice that we do not have x is less than or equal to 2. We just have x is less than 2. That means we draw an open circle on top of 2. This circle is not to be filled in. And then it says x is less than 2. So all the numbers less than 2 are to the left. So if they asked us to graph the solution, this little circle and arrow all the way to the left indicates the graph of the solution, or indicates the graph of the solution x is less than 2. Awesome. So we've done the graph. We've solved it. We've done the graph. The next thing we'll do is we'll say this in set builder notation and interval notation. So here's how we want to approach it. Let's start with set builder, which I won't use as much as I will interval notation, but both are good to know. So set builder notation, the way it usually starts off is we have some kind of set, so that's a little set brace there, and it's the set of x such that x is less than 2. This is set builder notation. So it's really not much different from what we wrote up there, right? Now, interval notation's a little bit trickier. Just a note, this little symbol up here means such that. So just to reiterate, sorry, just to come back to this, the set builder notation says this is the set of x values such that x is less than 2. It's just another way of saying this, except a little bit more formally. Now, interval notation, what we want to do is we want to capture what interval this is. What interval did we just draw out? And remember, intervals will always have the lowest number, lowest in this case, right? It's not actually a number in this case, but it's always lowest comma highest. So we take the lowest number here. Well, we see that this goes forever to the left, right? So the lowest, in air quotes, number of this is negative infinity. Again, being slightly informal, but that's what we write. We write negative infinity when it just keeps going to the left. And then as we travel to the right, we see that it stops at a value of 2. So it stops at 2, and 2 is not included in the set because we do not have x is less than or equal to 2. It has to be less than 2, so it doesn't include 2. Since it does not include 2, that means we do a parenthesis there instead of a bracket. So I think that's it for this video, guys. I just wanted to go over a pretty basic example that would show us how to use both the addition principle and the multiplication principle to solve an inequality, then to graph it, and then to write that solution in 2 different types of notation. But just bear in mind, this right here, x is less than 2, this set builder notation, and this interval notation, they're all equivalent. All of them are perfectly valid. All of them are fine unless a problem specifically asks you for one form or another. You're fine using any of the forms. So yeah, that's it for this video, guys. I hope you liked it, and we'll see you in the next one.